This is really an experiment, and I really appreciate you all joining me here, along with Pixelated Stock Photo Lady here. We will talk a bit about weighing your options for the climate. I actually brought a cheesy prop, so you can pass this around. You can try to see which one you think. There's no cheese in there, although if you dig around, you'll find interesting things. But you can see which one you think is heavier. There'll be a reveal somewhere in the talk, and we'll find out which one's heavier. I did want to say, though, first of all, that this talk is not about everything. There are a lot of topics concerning climate change. I'm not going to be talking about why it's happening. I'm not going to be talking about my own scientific research. I'm just talking about one very narrow topic here. And I'm hoping this is one that will be useful for us and kind of spark some discussion afterwards. This will be a very short talk, yeah, hopefully just kind of getting things rolling. So to kind of rephrase my title a little bit in a little more detail, the idea is if you are faced with many different options, different things you could possibly do, how do you pick one? What would be? How do you pick the best option? So some of the things that I'm thinking about right now, I was wondering recently, I was looking at all those fluorescent bulbs in the school. I was like, well, what if I just bought LED lights for the school? Would that be a good idea? My grandma's really sick right now, and I'm wondering, she's probably going to die. Should I fly to Minnesota for her funeral? Each of these things has a climate implication. That's obviously not the only implication, but there is a climate dimension to this. Should I insulate my home better? Should I get into politics? Maybe help with a campaign or even run for office myself? Is that a good way to spend my time? And is there a way I can help out here in Seldovia to help lead to some sort of climate action? And of course, that's why I'm here right now, and I hope all of you are here. So I'm hoping that something's coming out of this. I also am actually insulating my home right now. So a couple of those things that I guess I've sort of made a decision on. I want to spend a little bit of time on a semantic question here. The difference, these are different ways of comparing things. We have qualitative comparisons and quantitative comparisons. The classic example is comparing apples and oranges. You'll hear people say, oh, you shouldn't be comparing these two things. That's like comparing apples and oranges. What that means is that you're comparing two things that are qualitatively different. They cannot really be fairly compared because they are just fundamentally different. It's not about the weight being a little different or something like that. It's just that they're different things. You're comparing apples to oranges. You're comparing mangoes to rocks. Like whatever it is, these are things that are qualitatively different. Whereas if you really have two things that you think is fair to compare, you might say that you're comparing apples to apples. This is something where quantitative comparison might be really useful. So maybe a number. And this is actually when someone says, oh, you shouldn't be comparing these things, that's an apples to oranges kind of comparison, often that's a very fair critique. There are times when people will try to make comparisons that really don't make sense. But in a lot of cases, you can usefully and quantitatively compare things that are qualitatively different. So that's sort of what this talk is going to be about. I'm a geologist, and geology is actually, if you're looking amongst the sciences, it's a really qualitative science. The sort of work I did was very qualitative work, especially initially. But in that context, I had my geological elders there saying, you need to work on quantifying your work better. And that initially didn't make a whole lot of sense to me, but as I went through that process of sitting down and saying, okay, how do I actually assign numbers to these things, I began to appreciate what it is that trying to assign numbers to reasoning can do for you. One of the big things that it requires you to do is it requires you to confront your assumptions. So whenever we're trying to make a decision, we have to make a bunch of assumptions. And if you think very qualitatively about it, it's easy to miss some of those assumptions. Those assumptions can be hidden behind other things. But if you really have to assign a number, even if you just say, oh, I don't think this is important, so you put a big 0 there, that's part of one of your numbers, you do have to confront that and specify it in order to add things up. It also is one of the ways that one can prove oneself wrong, and that is super valuable because We all want, it's very rare that you go into a decision-making process and you don't want to draw a particular conclusion. So you need tools to help yourself prove yourself wrong. So I think that's very, very valuable. Repeatability is nice too. Some examples, though, where we use this kind of thinking that are not because we're scientists, but instead are in normal day-to-day life, would be like a personal budget. You write down all the numbers for your budget. It allows you to confront your assumptions about your budget. It can prove yourself wrong. If you thought this was most important, maybe something else is. Bathroom scale, I'm feeling fat today. Well, stand on the scale. I've done really good at losing weight. Stand on the scale. It provides a way to quantitatively test what you're thinking there. A schedule, those times on your schedule are quantitative information. The thermometer, rather than just kind of sticking your hand out the window. So what we need in order to make quantitative comparisons is some number that we can compare. In the case of those bags, it's weight. In a lot of cases, one thing that I think is maybe the easiest example looking at American life, where we make quantitative comparisons across things that are often qualitatively different, is price. If we're actually in that store and there are apples and oranges there, each one has a price. We may have our own preferences about one or the other, but that price can influence our decisions. So for climate change, now getting back to the subject at hand, we need some number that we can compare. So we're looking at different options we have that all have some bearing on climate change. Then what number do we compare? Does anyone know what the answer is in this case? Or what the answer that most people have gravitated to is? Carbon dioxide and carbon footprint, you'll sometimes hear it described as. And typically it's 1 metric ton of carbon dioxide is kind of the unit of measure. And so if it's at normal atmospheric pressure, it's about that much. And you add just a little tweak to that. You say it's a ton of carbon dioxide equivalent. Because sometimes the thing that's affecting climate is not actually CO2. It's something else that leads to warming. And so we use some sort of process to convert that into the same amount of CO2. And so some of the reasons why that is used, first of all, CO2 is the single biggest factor that's leading to climate change right now. So it's a pretty handy thing to be focusing on. It's pretty well understood. The first characterizations of how CO2 in the atmosphere might influence climate happened over 100 years ago. So we've had some time to kind of digest this, figure out what it is. So when you look at something that's more complicated, like black soot, for instance, then we have something to try to compare it to that we do kind of understand. And often we don't even have to add that equivalent qualifier on there because CO2 is the major climate contributor for many things that we might do. So a pretty useful metric. So I want to just jump from there right into some really concrete examples, things that might actually bear on life here in Seldovia. I picked these out a little bit arbitrarily. This talk is not so much because we want to nail each of these perfectly, but these are examples to kind of illustrate how you might use this kind of thinking to compare these dramatically different things. So first of all, one might have been considering flying to Hawaii. What if you didn't? How much would that influence your carbon footprint, the amount of CO2 that you were responsible for going into the air? Well, this one, there's a very straightforward approach. There are a number of different organizations that have created carbon calculators, and so you can put in, like, I'm going on a round-trip flight from Homer to Honolulu. How much CO2 does that correspond to? I went first to carbonfootprint.com, and they told me 0.7 tons of CO2. Really easy. I then went to a different carbon calculator, and I got a pretty different number, 1.9 tons of CO2. So this is both the good and the bad of this. It was really easy to get this, but I don't really know what assumptions went into this. And you could look at this, I think, and think, oh wow, this is terrible. We don't know anything here. But I'm going to suggest a different approach. I'm going to say, look at this and be like, somewhere around a ton. Yeah. That's a nice round number. Somewhere around a ton of CO2 to get to and from Hawaii. Okay, so let's say you instead decided to cut one of your weekly showers out every week. So you would take 52 less showers per year. Now I'll go through this one instead of going to a carbon calculator. That is, if you take a shower per week. It's hard to reduce when you're down to down as low as some of us are. But I'm going to go through and actually show all my assumptions in this case. Do the math myself. So in this case, I'm figuring out how much volume of water might be involved. Then how much do I have to heat that water? Then I have to come up with a specific heat of water. We could talk about the physics if you want, but I'm just going to run through this really quickly. You end up with an amount of electricity you would use if you're using electricity to heat that water. 165 kilowatt hours here, that if you were interested rather than in carbon footprint, but instead in price, that's somewhere around 35 bucks worth of water, something like that. And then if you go through and convert that into CO2 emissions, it ends up being about 0.1 tons of CO2. And this is based on emissions for the average of all of Alaska's electric grid, and which I got off an EPA site.
So that's about half a mile to Hawaii, is what you're saying?
Well, about a tenth of the whole trip.
A tenth of the trip, so
yeah.
A bit longer. But
yeah, so if instead you were saying, like, if 10 people were going to Hawaii, and one decided to stay behind, that would be the equivalent of all of them deciding to reduce by 1 shower per week. So, the bag weight. I brought this example in here as just like, this is something, these are two, like what's in those bags. Did anyone figure out what's in the one with the foam there? There's a if you want to screw it onto your boat, you can do that. It's a chunk of zinc in there to kind of, there. And I wanted to bring this out just as an example. They're qualitatively different things in there, yet we can compare them based on weight. If that's what we cared about, we can do that. I also want to say that the answer does not matter. They weigh about the same. There are very few cases where you would care about the difference between the weight of those two. They're really close. I did weigh it though, and the firewood is a little bit heavier.
Good.
How many people got it right?
You just redeemed yourself.
I'm telling you that foam bag got a little more.
Well, you know, it's hard because you can only kind of fit one finger in the foam bag thing, and you can get your whole hand on the other one. I don't know. I found it difficult to compare them. Okay, so imagine you were instead buying an electric car. I'm going to go through this one really fast. You could start out looking at making a few assumptions, looking at how much gas. You know, your current car, I'm imagining it's kind of this gas guzzler, and you live 3 miles out like we do, and you make a trip every day, ends up being a couple tons of CO2. However, with an electric car is using electricity, so you need to figure out how much CO2 is produced by that. It turns out our electric grid is mostly run off of natural gas, so it's actually fairly carbon intensive, meaning it produces quite a bit of CO2. And in this case, I was kind of surprised at the answer. So the answer is that the electric car appears to consume more or produce more CO2 than a gas-powered car. This is not typical for the United States as a whole. When you look at analyses of the average person and the average, across the United States, then you end up with about 30% savings in CO2 emissions, but not here. It also, if you were doing this, you'd also have to be thinking, am I buying this car to replace something, or is it is it a whole new car? You have to think about how much CO2 goes into making the car. Another one, eliminate all single-use plastics. I looked at some average numbers for an American, ended up being about 0.3 tons of CO2. Now this one was kind of interesting. I was thinking, oh, this is something you don't see in a carbon calculator. If you drain a bog, then you basically expose all this plant material to oxygen, and so it can oxidize. And I picked like a little 1 acre bog and came up with really a kind of tremendously large number. There's a lot of carbon stored on that bog. You drain it, that carbon ends up converting to CO2. Worse yet, it might convert to methane. So, quick summary there. Our trip to and from Hawaii happens to be about a ton, which is really nice. As like kind of keep that in your head as like a point of comparison. Shower is 10th that. Electric car is probably not your best climate solution here in Seldovia. no single-use plastics, fairly substantial, and land use around bogs could be a big deal. And so I'm going to stop there. I'm going to just put up this, oh yeah, there's our apples versus oranges comparison we did. I'm going to put up this, which has a few notes of things that are pretty high impact.
Can I take off the lights all the way so we can maybe see that better?
Yeah, it's a little hard to read in there, isn't it? There we go.
Oh.
But I would be, I'd be really happy to take any questions. I'm hoping that this is a lead-in to some conversation after that. So maybe before I take questions, I'll say kind of what I think we can do next. We can
You
take some
should read
questions.
those out loud so people.
Yeah.
can
Sure, I'll do that. So the list here is flying, buying new things. So whether you're buying a new laptop like I just did, or a new car. Beef, lamb, and goat meat turn out to be particularly high impact. Milk products for actually the same reason, basically. Land use change. So this would be like whether you're cutting down forests or you're doing something. This can actually go either direction. It can have a big impact in either direction, but there are large masses and there's a lot of surface area involved there, so that can be a big deal. Fossil fuel generated electricity, so whether it's natural gas or coal. Heating buildings and heating water. I mentioned heating water just because there's a lot of heat capacity in water. So if you're going to heat up water, you're going to spend quite a bit of energy.